Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us now begin solving this step by step. The starting material is 7-bromocyclohepta-1,3,5 tropylium bromide precursor. It has a 7-membered ring with 3 double bonds and a sp3-CHBr at C7. Moving on to the next step. AgNO3 abstracts the bromide ion, forming AgBr precipitate, generating the tropylium cation, cycloheptatrinyl cation, C7H7+. This is a classic ionization driven by exceptional carbocation stability. Moving on to the next step. The tropylium cation is a planar, cyclic, fully conjugated system with 6 pi electrons, 4n plus 2, n is equal to 1. By Hückel's rule, it is aromatic. So statement A is correct. And for the final step, the tropylium cation is a charged species, full positive charge delocalized over all 7 carbons. Charged ionic species typically have high dipole moments or are ionic in nature. Statement B, saying it has high dipole moment, is effectively correct for an ionic charged species in solution context. The tropylium cation has very high resonance energy because it is fully aromatic, 6 pi electrons over 7 carbons, all equivalent by symmetry. Saying it has less resonance energy is incorrect. It actually has exceptionally high resonance delocalization energy due to aromaticity. This is the incorrect statement. The product is an ionic species, propylium salt, propylium nitrate after ion pairing. Ionic compounds are soluble in polar solvents. Statement D is correct. Statement C, claiming the product has less resonance energy, is the incorrect statement, since the tropylium cation is aromatic and has very high resonance stabilization energy. Therefore, the correct answer is C. Therefore, the correct answer is option C.